have a partial inequality, equal sign, excuse me, but it's not just an equal sign. All right, so inequalities, oh my, there we go. This is what I want to underline. They may not be equal. These are the symbols that we use most often with inequalities, and this is just a review. Now, when I went over with 7th graders, I told them, here are the symbols. And they're like, wait, Mr. A, is that the alligator eating that side or this side? Yeah. Is that the bird pecking at this side, the smaller seed? I'm like, yes. Okay, by 8th grade and beyond, you should be getting to the point where, I can look at the symbol and I can say, this is less than, this is greater than, and then this third one, whoa, that's kind of strange. Do you guys see it's just an equal sign with something going through it? What does that slash mean? Not. It is not equal to. So you're going to see those sometimes. Okay, but then we also have 2 other symbols that we use that are related to the first 2 here. And these are ones that we're going to get a lot of as well. The less than or equal to and the greater than or equal to. So that word or is important in math. Because or is not and is not or, even in English. Davis and I will play soccer today. What does that mean? Both of us will play soccer. Davis or I will play soccer today. One of us is going to play. So here, does it mean that it has to be less than and equal to? That hopefully doesn't even make sense to you. It means one or the other. One or the other. Okay, so or and means something. And lesson 3-6, it's going to mean more to you. The words and or. Because we're going to deal with solving inequalities, which is a little bit tougher. Okay, so here I need to get 2 words because we're going to deal with... this way. Okay, you're good. We're going to deal with translating, and so I need to get 2 words here. This phrase I want you to get is at most. When you look at the less than or equal to, you're going to deal with at most. Sometimes it's translated. And then the bottom one, the greater than or equal to, would be at least. Wait, is that supposed to be flipped? Is that supposed to be at least, at most? Okay. Some people think, well, Mr. I don't know if you meant to put at least up here and at most up here, but the answer to that is no. Let me give you an example at least. How old do you have to be to drive with a license by yourself in South Carolina? What's that age?
At least 16.
16. Is it 15 and a half?
It's 15. 15 is for a permit with an adult.
Okay, but without an adult, what's the youngest you can be? Okay, 15 and a half. So I would say, in order to drive in South Carolina by yourself, you need to be at least 15 and a half. So that means you have to be 15 and a half or above, greater than that, right? So that's why we use the word at least. And at most, which is a cool illustration. You guys know about Kangaroo Jacks off Lawrence? Okay, it's by Sky Zone. Have you ever been to Sky Zone? So there's Sky Zone for big kids, and then there's this little place called Kangaroo Jacks. And Kangaroo Jacks, the reason you probably don't know about it is because it actually just opened up maybe a year or 2 ago. And by that time, you're like, I'm not going to Kangaroo Jacks. I might as well go to Sky Zone or that other place. Those other places you can go. Yeah, Gravitopia. All right. But at Kangaroo Jacks, a child can be at most 12 years old. So what does that mean? They could be 12, or they could be anything that is less than 12. Less than 12. Unless there's one exception. One exception. You are an adult. Yes. Because I get to go. If your kid is under 3, I think, you can have a parent supervision person, anyone, guardian or grandparent or anything. So as much as my boys have fun there, guess who else has fun there? Yeah. I do. I get to go through these inflatable obstacle courses, and I get to go with my son Titus. I guess he's this tall now. Titus is 1.5. He weighs, I think, 30 pounds because this dude's a big. He's a clunker. Yeah, he's a block. So imagine carrying a blocked-in obstacle course, not on your back. You have to carry it here. So I was going through an obstacle course. I'm carrying it here, and it's those inflatable walls that you have to climb up the steps and then go over. So I'm carrying them because I don't want to just toss them over. So I'm trying to go over like a weird, awkward way. And I get over and I fall, but I keep him the right way. And he slobbers all over my face and laughing. And I did that because after we get at the end of it, I'm like, okay. And he runs to the beginning and he starts calling out. And I'm like, okay. So we go 6 times. Every time he laughs after going over the same hurdles as he slobbers on me and gets me all wet. But it was awesome.
Put him on like a backpacker.
So at Kangaroo Jack's, Titus and Ezra get to have fun, and anyone who's 12 or under, except for adults. We can go and have fun, and I enjoy it.
That doesn't seem fun.
It is. Well, yeah. If it were just doing that, it would drool all over your face. No. But yeah, with my son, it's fun because he's laughing. He gives this laugh that he's enjoying it. I'm just like, it's cool. It's hard to say no. You got to know what at most and at least is. Make sure you match it up with the right inequality. All right, next. Graphing solutions. So this is review, but this notation right up here is maybe a little different than what we've seen in the past. Write it down, I'll interpret it for you, and then we'll graph it together. Okay, this is how I would read it. A is any number such that, dun, dun, dun. I'm going to underline such that, and then I'm going to do this with that line. I'm pointing to that little symbol. Is that an absolute value symbol? What do you think?
No.
Why not? It looks like it. There are absolute value symbols have pairs. This one it's by itself, and we read it as such that A is greater than. Do you know where the greater than comes from?
Yeah.
Or equal to, and I'll just put -5. So I just translated that statement. That's what we call a set builder notation. Wait, set. Replacement set. Solution set. Any of those ringing a bell?
Yep.
You guys remember we talked about sets? How do I know I'm dealing with a set up here? The braces. You see these braces here? I know I'm dealing with a set. So I read it. A is any number such that A is greater than or equal to -5. All right, who wants to read that for me real quick? Yes, Sarah?
A is any number such that A is greater than or equal to -5.
Good. Now you're like, Mr. A, it seems like you're kind of just saying words. Sometimes A cannot be any number. It can only be an integer such that A is greater than or equal to -5. Or A has to be a rational number such that A, okay? So there's sometimes we do restrictions on it. Just giving you exposure to this will help you later on. Okay, how do we graph this? This is what I want you to do, those who are going to fear the 10,000 graphs that I'll make you do today. Excuse me, sorry. This is how I want them. You put the number in the middle, and then you just go one above it and one below it. I know. Uh-oh, you're going to hate this chapter then. Yes, ma'am.
What does such that have to do with the equation?
Or the inequality?
Yeah.
Yeah, it's just saying A is any number. When it just says the letter A, you can say A is any number such that A is greater than or equal to -5. So it's saying A can be any category number such that. So it's being more specific. So A could be any number, but that's such that it has to be greater than or equal to -5. Because later on we're going to have A, I'm going to put A is an integer such that A is greater than or equal to -5. That means it can't be any number, but it can be an integer that is greater than or equal to -5. So we'll be more specific, just letting you kind of see this and write this down.
Once you find out what A is, would you put it where both A's are?
Yeah, you could do that, or really you just need to put it in the second part, because A could be any number. So yeah, you're going to put it there. Now, how many solutions are there for this inequality? How many numbers fit this description?
Infinite.
3, and then 3 more, and then 3 more. Okay, infinite. So how do you write all those infinite number of numbers? You can't. You do it with the number line. You draw it out. So what kind of circle, hopefully this is a review, what kind of circle goes on -5? Look at that inequality. What kind of circle? Closed. So I draw that little closed circle. By the way, guys, make it clear to me, if you draw this like little circle, and I can't tell if it's filled in or not, Mr. A was not, it was closed. Or no, that was open. I can't tell. I have to mark it wrong. So please make sure it's closed. It doesn't have to be perfect, but it just has to show that. Okay, where does the line go?
To the right.
To the right, because greater than refers to the right. That's correct, I mean. Okay.
Left hand.
Yeah, I got to practice with that. Okay, you guys okay with the graphing?
Yes.
Okay, do you understand that greater than means to the right and less than means to the left? Do you guys get that? Always like that. Yeah, you can always think that way. Greater than is always that way, less than is always that way. And for me, I'm going backwards, so I have to flip my mind.
Right? Because if the variable and the number are switched, you have to switch it.
Variable.
Like if the side they are on.
Gotcha. Let me give you another example here. All right. Like this?
Yeah.
Okay. Someone read this inequality for me. Jensen, just read it for me. Just the way it is.
6.5 is greater than m.
Good. 6.5 is greater than m. Now, some of you are just like, I hate that. I hate that variable being on the right. Why? Why? Okay. No, it's actually m. But can you flip it? Okay. Can you flip it? You can. You can flip the numbers around in the variable. But what also has to happen? The sign has to reflect that. Mr. A, but I don't get that because then you just change it. It was a greater than, now it's a less than. But did I change the actual statement completely? Out of these two, which one's bigger, m or 6.5, according to the top? 6.5 is bigger, right? According to this statement, which one's bigger, m or 6.5? It's still 6.5, so it didn't change it. Now, what I want you guys to do here is I want you to just graph it. Now, on this graph, notice that's 6.5. So this is all you have to do. I would even just do 6, 7, and 5. So I'm just going to put these numbers. Don't forget the correct order for it. And then where would 6.5 go?
Between 6 and 7.
Yeah, right between. For me, I just draw a little tick mark. And what kind of circle should go on 6.5? Open circle. How do I know it's open?
Because it doesn't have an equal.
It doesn't have the equal to sign down there. It doesn't have the line underneath. So it's just less than 6.5. Where does that arrow go?
To the right.
To the
Left.
left. How do I know it's to the left? Less than is always to the... Now, less than is always to the left and greater than is always to the right if your variable comes first. So you see here, wait, Mr. You just said it goes to the right this time, doesn't it? But where's the variable?
To the right.
It's on the right, so you have to kind of flip it around. Basically, just answer or just write what is being described. And there are tricks, but understand what you're doing. All right, Murphy.
For the last one that we did, yeah, wouldn't it be, oh, I wrote it down wrong.
That's okay.
I just wrote it. I thought, I was like, the 6 is supposed to be on the left.
Gotcha. I see.
I just wrote it down.
That's okay. John?
So I put 6 and then 6.5 and then
That's
7
fine.
for my line.
Yeah, you put 6, 6.5, 7. That's
Yeah.
it. Fine. Sarah?
Wait, so the variable thing, what were you saying? 'Cause I'm still
Yeah,
confused.
you see, the arrow goes to the left, and it shows it right here, right? It shows it right here. I should say correct because right is right. Correct is right. Right, no. Right is left. No. Okay, looking at the direction of the arrow, I can go with that direction if the variable was on the right side. So, like if I try to graph this, don't make that arrow go to the right because it's pointing right, because where's that variable?
On the right.
It's on the other side, so you got to flip it.
Is the variable on the right, flip it?
Basically, you can think of it that way. But see, there's a lot of rules there. But that's why I say which one's bigger. This one's bigger, so M should be smaller. M is smaller. Okay, you guys good on graphing? That's a review. Okay, Whoa, my goodness. Take this down, please. A lot of notes here. Dun, dun, dun. Interpretation of symbols. Now, parentheses. Have we dealt with those before? Of course we have. With order of operations. And even with points on a graph. But this time it's going to be used differently. Like, Mr. Ray, how do you know if it's this one or that one? Well, we'll talk about it. And then you're also going to use brackets. Have you used brackets before? Yes. Order of operations. I think that's what we've dealt with it mainly. Yep. But now we're going to use it for a different notation. And then, have we dealt with these yet? Have we used these before?
Well, we know what they are.
We know what they are, right? Hopefully you guys are at least familiar. But these are not figure eights, but infinite signs. You have positive infinity and negative infinity. Yeah, go ahead and take that down because we're going to need to know what these words mean. This is your key, by the way, to interval notation. This is going to be a different way of writing it, and this is your key. So if I ask you a question and you look at me blank-faced, I'll say, look at your key. That means look at this. See if that helps you out.
Do you want us to use that much space to the closer something in it?
Oh, right here? Oh, that means if I wrote continues infinitely in, and I put these little quotation marks, that means I would have repeated continues infinitely in. That's okay. That might be new for some of you guys. Maybe because my hand was getting a cramp writing all this down, so I just put those little... Guys, another a good thing for taking notes. Instead of writing that all over again, you could use these little quotation marks in your notes, not on like term papers. Miss Pennell, Mr. A told me just use quotation marks because I already said it. That's not how it works. This is for like note taking. Positive direction, negative direction. Is there a difference between those?
Yes.
Yeah. Positive direction goes which way?
Right.
To the right. Negative direction goes to the always?
Always.
Always. So where does positive infinity go?
To
To
the
the right. Right.
Right.
Left.
And negative infinity always goes to the left. Always. You can bank on that, and that's going to help you interpret what we're doing here. Okay. Once you get that down, I'm going to go to some examples of how to use interval notation, which we haven't dealt with before in our class. It's okay. All right. Let's look at an example. We're going to actually look at two examples of set builder, interval, and then graphing. Okay. Here's a set builder notation, and I want someone to read it after I write it. So it's like a little chart. We'll just do two examples. All right. How do I read this set builder? Caroline?
X is such that...
Is any number, sorry.
Oh.
Yeah, it's kind of all there. X is any number.
X is any number such that X is greater than or equal to negative 3.
Okay, good. Matt, read that for me. X is any number. And what does that symbol mean? Such.
Such as X is greater than or equal to.
Yeah, X is any number such that X is greater than or equal to negative 3. Emma Grace, read that for me. Sorry.
X is any number such that X is less than equal, greater than equal to negative 3.
Okay. John?
Couldn't you just write it as X is greater than or equal to negative 3?
Yes, you can write it just like this.
Yeah.
Yeah, but when set builder notation comes in, we're going to start putting restrictions up here. And this is, you're going to see X can only be a negative integer, positive integer, natural number, real number, irrational number, imaginary number. So that we're going to make it more specific. This is just the beginning. Okay, interval notation is a little tough, so ready for this, guys? Before I get to interval notation, let's graph it because that'll inform your interval notation a lot easier. So graphing it, negative 3, negative 2, negative 4. So I put them in the right spots. What kind of circle goes on negative 3? Somebody?
Close.
Why closed?
Because it's equal to.
Also equal to. So if it's equal to, it's a closed circle. Line going to the Right. So, I think I heard right.
Yeah.
And if you said left, it's okay, but just make sure you know it should be to the right. Yes, ma'am?
Sorry, I'm
That's
just
okay.
making sure.
Mhm.
So the variables on the left, so greater than right. The variables on the left is less than. It's still to the left. Versus to the left.
Yeah, okay.
It's on the right.
If the variable's on the left, follow that arrow.
Okay.
So it's going to the right. If it was the other way, follow it.
Variables on the right, switch it. Okay.
Yeah, you switch the direction.
That's my last question about that.
That's okay. No, that's all right. And just make sure, actually, can you check these solutions?
Yeah.
Yes, pick a number that is equal to -3 or greater than that. Pick a number. Go. Easy number. 0, great number. 0's over here. Bless you. Is 0 greater than or equal to -3? That's why it's highlighted. Pick a number that's not a solution. -4. Is -4 greater than or equal to -3? That's why -4 was not highlighted. Do you see how you can check them? All of them.
So if, like, you said we had to get a positive number for that, if we put, like, restrictions on it?
Oh, yeah.
Would 0 count as positive?
No. 1 would be the first positive integer, for example.
So it'd be 1 and then an arrow going to the right.
Yeah. So I can say x is any positive integer. So you'd start with 1, and then it wouldn't even be a line. You'd put closed circles on 1, 2, 3, because it doesn't include everything in between, only integers. But see, I don't want to introduce that today because then we're like out there. Okay. Interval notation. Okay, this is how I'm going to write. Just write down.
Wait, why is one?
So write it down. We'll talk about it. I'll tell you why everything's where it belongs. Okay, don't be afraid of this. Remember, what did I say? Refer to your key. Where's the key? It should be written in your notes. All right, look at the key. What does a bracket refer to?
Included or closed?
Included or the word closed. Closed? I've heard that before today. Closed. What kind of circle is on -3? Closed. So this is designating that there's a closed circle on -3. That's what we're saying there. Now, why do I put an infinite sign, a positive infinity sign on the right? Because it keeps going to the right. So that's how I got that. But Mr. A, there's a parenthesis there. Why is it not a bracket? Why is it a parenthesis? That's weird.
Because it's not.
Does it ever close off in the positive infinite direction? No, it keeps going infinitely. So do I put a bracket to show closed? No, I show open to show it keeps going forever. So basically, whenever you have an infinite sign, you should have parentheses right next to it. Can we say that? Always. Always. If you have a number, you may have a parenthesis or a bracket, depending on the type of circle. I'll give you another example. We'll keep doing this.
So you're saying it's never closed because it's
With the infinite side, yes. Exactly. Yep.
Why do you need like 2 infinite symbols on like the right side of your like? Why do you need that?
Oh, no. This symbol right here, this means open. So it's just saying that it goes infinite that way, and I have no more closed. I have no barriers. It just keeps going that way. So it's not technically, this parenthesis just means open or included, not infinite. And I'll show you why in another example. Not this next one, but in another one. All right, let's go through another one. And let's see if we can get this. Who can read this next one after I write it down? Sarah?
X is any number such that x is less than or equal to 1.
Perfect. All right, that's it. X is any number such that x is less than or equal to 1. Okay, great. I do not get interval notation yet, but do I know how to graph it?
You know.
Okay, let's graph it. I'll go with 1, 2, 0. What kind of circle goes on 1? What kind of circle?
Close.
How do you know it's closed? There's an equal to, remember, equal to signs, so less than or equal to, greater than or equal to, are always closed. And that's okay if you don't remember, but now you need to remember. Yes?
Is the greater than itself open?
If it's just a greater than, for you guys like this, it's open. If it's just a less than, open. But if it has that little equal to sign, it's got to be closed. Okay, which way does the line go here on the second one? It goes to the left. Okay, so line going to the left. Again, this is review, but if you totally forgot, it's okay, but we're getting refreshed on this. Now, here's how interval notation is going to play. Well, does anyone want to take a guess of what to do? Jensen?
Would it be the open, negative, infinity?
Okay, what do you mean by open? You mean...
The parentheses.
Okay. And then you said...
Negative, infinity.
Yep.
And then 1 and close.
Bracket. Yep, that's it. Whoa, Jensen, did you get my notes? Did I post this online or something? Okay, Jensen, why is this a parenthesis? It keeps going that way. It never closes off. It's always going to be open to the negative direction. Why is there a bracket on positive 1? Why is there a bracket here?
Closes off at 1.
It closes off at 1. Can you have a parenthesis next to the number? Yes. Have we had that example yet? No, we've had brackets by the number each time, but let's go through one where it doesn't happen that way. Okay, Betsy.
Why is there a negative sign next to the infinity sign? Because it goes...
Yes, it goes negatively. It goes infinitely to the negative direction. Infinitely to the positive direction. Okay, yes, ma'am?
Could there be like more than one number in
In that, yes. That's later on. You can have an open circle on one number, open circle, and a closed circle on another, and you could say it's everything in between, and you would have two numbers, no more infinite, because it has barriers on both sides. Dick, good question. Nick, go ahead.
So you can't do the interval notation with the graph.
Can't do that. Oh, so this is what the problems are going to be. The first problems you're going to do are going to say, write it in both set builder notation and interval notation.
So
You got to write it both ways.
you want to do a graph to do something.
You could, yeah, if you need a graph to do it, you can, but you're going to find out later you don't need that graph necessarily, or you could just picture the graph. Like,
We'll figure that out today.
yeah, some of you, not all of you. I can't promise that. Yep.
So I have someone just asked this question, but so you're just like for homework, you're just gonna give us like one of them, and we do like the other two.
That's part of it. Like I'll say, I'll give you this, give me the other, or I'll give you this, give me the other, or I'll say, give me both. And then there's a few graphing, not many. Yeah, and you'll see it'll be clear in your instructions. Okay, let's do a problem together, or yeah, together, I guess.
We just worked on closed circles, so we're allowed to do it with open too.
Yes, and I'll.
Oh yeah.
All right, this is the instruction for number 5 on page 71. So let's see how these problems play out. Okay, on number 5, rewrite each solution set in a different symbolic notation. What are the two options we have for notation? Set builder notation and interval notation. So in this case, you write one or the other. One or the other. Or the other. Not both. You just do one or the other. I'll do both. Some of you are going to go this route. Some of you are going to go that route. All right, set builder notation. Guess how I know it has a set? What symbol has to be in there? Braces. Yeah. So I'm going to go H is any number such that H is less than 4. That's set builder. Guys okay with that? Set builder, you can go right to it. No problem with that. All right, interval notation might be a little bit tougher, but I think you guys can, I mean, at least try it. And if you botch it, that's why we write in pencil. Yeah, and that's okay. We'll learn from that. Caroline, you want to try it? Awesome.
Yeah, that question.
Oh.
I'll try it though. But
Go ahead, give me the question.
how are you supposed to get your interval notation without the graph?
I want you to try it. So, Caroline, can we do this? Ready? Watch this. Picture the graph in your head. What kind of circle do you get?
Open.
On what number?
4.
Okay, open circle on 4. Where does the line go? For you guys, to the right or to the left? Okay, so it's going like this. All right, ready? Something like that? That's all right. I'm terrible at mental math, guys. Right now I'm like, this is really helping me out because I got to keep track of what's going on.
Okay.
So
So, a parenthesis.
All right.
Okay. And then
It's going to the left.
the left, so it's negative infinity,
Whoa.
comma,
And then.
4. No, wait. Yeah, 4 plus. Right? What? Oh, wait.
What kind of circle was it?
Open.
You got close, and that's hard. I'm thinking, I hope Caroline gets it because I don't want to be able to get it in my head.
Then 4 would be in the equation, which it doesn't work.
No, see, here's the cool thing. Ready? Look at your key. What does a parenthesis mean? Not included.
Oh, okay.
I love it, guys. That key is going to help me out. So what does not included that means there's nothing to stop this arrow going to the left, but then 4 is not included right here. So that's the cool part. All right, that's interval. And then it says to graph it. So now you can graph it. Sometimes you graph it, sometimes you don't. So you can do it for everyone if you want. Like Nick, you said, are we all going to get it today without graphs? No. So just graph it. Then let's see if we match up what we got here. What kind of circle goes on 4, Betsy? Thank you, whoever whispered that. But
I knew it was open.
good.
Because it doesn't have the little equal thing.
Very good. That's it. That's a good explanation. Where does the arrow go, Emma Grace? Or the line go? To the left, because it's less than. Okay. Look at your graph and look at the interval notation. Do you guys notice that it has a starting point right here on the right and it goes infinitely to the left? See how the 4 is on the right, infinitely to the left? That's shown right there. So that,
I just don't get why wouldn't it be closed.
the 4?
Yeah.
Because what kind of, is 4 included?
It's open, but
And then it's saying,
go to the right though.
I see what you're saying. If it had the infinity sign, you would go infinitely to the right. But it's saying there's a barrier 4, but it doesn't include that. Yeah, it doesn't include that 4 itself. Yes, ma'am?
So since the original problem was h is less than 4, wouldn't you just use 4 the time, like for the interval? Because,
Yeah, 4.
Yeah, you'd
But
always
then,
use 4. You wouldn't use like another number.
no, you wouldn't use it here. Later you will, not today. We're just getting used to this.
Yeah.
All right, this. It's going to say, write this in another notation.
Only one of them? Or both? Another?
Yeah, so here, did they give it set builder? So do they want set builder? Nope, they want interval. So go ahead and try it out. You can do it with a graph if you need it. You don't have to use a graph. On interval notation. So I know I'm going to have two things with a comma in the middle and some type of symbol causing that barrier. I'm not doing it. Sorry?
So we're writing.
The interval notation. This is set builder. This is set builder. I don't want set builder.
Okay, duh.
Don't hurt yourself with that. All right, I know who I'm asking. All right, now it's time to ask. I want interval notation. Alyssa. Okay, she's going to say parenthesis 16.
What the heck?
Whoa. Okay, first of all, who got that? I just want to know who got it. Okay, if you did not get it, give me a question. Raise your hand. So if you didn't get it, give me a question. All right, question.
Why do you put the 16 before?
Yeah,
I can answer that.
Yeah, I didn't.
Answer that.
Because if it's facing that way
To the right?
to the right, then you put the number in front, and if it's facing to the left, then you put the infinity in.
Yeah, basically you can think of it this way. Can I give you another helpful hint? How many of you knew it was positive infinity? Okay, positive infinity always goes to the, so I always write it going to the, negative infinity always goes to the, so if you had a negative infinity, it would go here on the left. That's another way. Yes, ma'am.
Okay, so I did a bracket and then 16, and then I got everything else right.
Good. So why not the bracket?
See, I thought you put the bracket because I thought you put the bracket when it stops. It doesn't go that way.
Okay, how about this? Think of the bracket, look at the key. The key to your success.
Not included.
So that means 16 is a barrier, but it's not included itself. Yes, ma'am?
I don't know what you mean by like not included.
That means, yeah. Here on my solution, 16 going to the right. Is 16 an actual answer to the inequality? Is 16 greater than 16? No, but everything after 16 is. So 16 is where the barrier begins, but it's everything right after it. Yeah, and if it were a closed circle, that'd be equal to 16 is greater than or equal to 16. Yep. So that means that's the barrier, and it also includes that barrier. It's kind of like this. In order to, what's the thing? I had an example about an age where you have to be, you know how they say 18 or older? That means you could be 18 or 19, 20, anything above it. But if I say you have to be older than 17, what does that mean?
18 or older.
18. If I say older than 17, that's the barrier, but it means everything 18 or above. Yeah, technically, from what I said, you have to be a day older than 17. Something like that.
Okay, so...
Oh, sorry. Go, Marissa. Sorry.
Oh, I'm sorry. Okay, so if it was less than or equal to, so it'd be a closed circle.
Be a closed circle, line going to the left. And it'd be 16 would be here, bracket, and then negative infinity, parenthesis. Basically, infinity signs always have parentheses next to it, right? Parentheses are always next to infinity signs, always. Yep, that's right. Go. Graph it. Go ahead, give me your question. I'll give them this.
So it's open. So both sides.
You can think, well, yeah, for the most part today, parentheses on both.
Right. So why does it matter which side you put 16?
Because you're trying to show the direction positive infinity this way, right? Positive. Negative infinity this way. So I mean, you could switch it, but it's kind of like you're doing this. Well, no, I'm saying like theoretically you could switch it, but you're kind of drawing something like that. You're going opposite of what it says. So just give it the direction it is stated in. I know that's tough, but you get used to it. All right. Interval notation actually helps me with my graph. I know 80's on there. What kind of circle goes on 80? Closed. How do you know it's closed? Bracket. That means what according to my key? Closed or included. It means this. And then what kind of, where does the line go, Jensen? To the right.
Could you still write it as what's that called?
Set builder?
Set builder, even though you don't have a variable?
Yeah. Actually, write in set builder. Go. Write in set
I
builder.
already did that.
Good. So what you do is you just pick a variable. Just pick a variable. Boom. X, H.
Were you supposed to write out in the graph as well?
No, I just told you to graph it. Now I'm making you write set builder. Oh.
But when they tell you to write it in a different way, and they give you
Want like this? You want set builder.
then you want subbuilder, not graph, because graph's not an interval.
Yeah, I'll say write it. It'll say write it in a different notation. So write it in a different one, or write both notations, both, or graph. Okay. Set builder. You can even pick the first letter of your name. I know, customized to you. Murphy?
Can I read it?
Yes, go ahead.
Okay. Z.
Oh, Z.
No.
All right, let's go with Z.
Oh, sorry. M.
Oh, M for Murphy. Got it. Murphy, okay. All right. Go ahead. M is any
N of any number.
is any number.
Is any number such that n is greater than or equal to 8.
Yep, that's simple.
I like those
Did
practice.
you get that? Did you get B is such that B? Do you guys, how many of you are like, if you just give me the graph, I can get these. If you gave me the graph, I can get them. Then draw your graph if you need it. How many of you are like, I don't need the graph, mister, I got it. Then you don't need the graph. How many of you, if I could get it in my head, I can get it? Okay, whatever you're in, use what you have. Because you have a key, and this is only homework, not a quiz yet. Okay, your homework. Yes. I modified it 8 to 30 even.
Okay, good.
Wait, we're doing it. How much time do we have?
3 minutes.
We have 3 minutes. Yeah.